Alright guys, so let's have a look at electron shells. Let's get specific with their atomic structure. In particular, electron shells. How the electrons are orbiting. So, what we know, the example, by the way, that we are going to use is this one down here, which is neon. Okay, so that's our key example. So, electrons, they orbit the shell, so they orbit the nucleus in shell. If you want to imagine a large sprawling city, right? So, say, Los Angeles, Sydney. This first electron shell, if that was the size of that big city, that big sprawling city, this nucleus would actually be about the size of an orange. They are really small. The nucleus is really small compared to the electron orbits, but we always draw them as a bit larger just to make our diagrams easier. But keep that in mind, that most of what you're looking at is actually empty space. And it's just sort of, it's repulsive forces. Anyway, that doesn't matter. What matters is that the nucleus itself is actually really, really tiny compared to the orbits, but we draw it larger just so we can see what we're dealing with. The shells closest to the nucleus fill up first. Okay, and this has to do with the shells also being energy levels, but we'll get to that in a second. Each shell has a limited amount of space, therefore a limited number of electrons. Okay, so we can see this here. The first shell is actually quite small, so it can only hold 2 electrons. Okay, remember the electrons repel each other a little bit so they don't get too close. The second shell out can hold 8. The third shell out, or shell M's, okay, so we go K, L, M, N, just like the alphabet. The third shell, M, can hold 18, and the fourth shell, N, can hold 32. Just pause for a second and see if you can work out what the pattern is, and then I'll tell you once you've unpaused it. So pause for a second now, and I'm assuming you've paused and tried to work out what the pattern was. The pattern is actually pretty simple. So it's shell number, so number of electrons in the shell is 2n squared. Okay, so 1 squared is 1, times that by 2, 2. 2 squared is 4, times that by 2, 4. 3 squared is 9, times that by 2, 18. Shell 4 squared is 16, times that by 2, 32. Now, this number is important. An atom is stable if they have an octet in the outer shell. That means 8. So if they have 8 electrons in the outer shell, they're stable. They won't tend to react with much. Now, have a look at our example here. We've got neon. It's got 10 protons. That's the red ones. They're all in the nucleus. 10 neutrons. That's the blue ones. They're all in the nucleus. But it's got 10 electrons. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we look at that outer shell, 2, 4, 6, 8, we have an octet. Neon is a noble gas, which means it actually doesn't react with anything. It's stable. It just exists on its own, and it's very, very hard to get to react. You've got to put in a lot of energy to make that happen. So let's think of electron shells as energy levels. Now, electrons, because they're negative, they're attracted to the positive nucleus. That's the easiest place for them to be. Now, to move them away from the nucleus, it takes energy. So the further away a shell is, the more energy it has. So the further shells are away, the more energy they have. Now, electron shells, this is actually really important, are discrete, and an electron cannot live or cannot exist in between shells. So you can't have it in shell 1.5. That doesn't exist. It does not exist in 1.5. So what happens is, as an electron moves up, energy is put in. And we'll see that here. So we put energy in, and it goes up. But once you take that energy away, the electron will go back down. Now, because you've put energy in to move it up, the electron will move back down, and it has to release energy, because otherwise it breaks the law of conservation of energy. So it releases energy, and when an electron releases energy, we call that light. So electrons move up, they get all energetic, and they come back down, and they release light. That's what fire is. The part of the fire we can see, that is that's electrons being like excited, so they move up levels, and then they calm down, and it just keeps happening over and over. And as they calm down, they release light, and that's the light from fire. Alright, I hope that made sense. If it didn't, ask any questions in the comments below, and we'll get back to you as soon as we can. And yeah, thanks for watching. We'll see you next time.